take a look at inscribed angles. Right? An inscribed angle is just an angle whose vertex is on the circle. Right? So angle DEF would be an example of an inscribed angle. Right? The property that we're going to look at is that the measure of an inscribed angle is exactly 1/2 measure of its intercepted arc. Right? So, in this example up here, they're saying that arc DF is 90 degrees. Because they said so.
See, they can be lying too.
No.
Maybe they are. Right. So, if I know that this arc is 90 degrees, its inscribed angle would be exactly half of that. Angle DEF would be 45 degrees. Right? Now, the kind of interesting thing here is in asterisks, it says if two inscribed angles intercept the same arc, or even congruent arcs, then those angles are congruent. So what that means is I could have some other angle, like right here, right? Say that's point Z. Well, if that angle, DZF, intercepts that same arc, we automatically know it's going to be also half of 90. That angle would also be 45 degrees. Right? Any two angles, or any number of angles that intercept the same arc, have to have the same measure because of this property. Right? An inscribed angle is equal to exactly half of its intercepted arc. Right? So, I guess I should mention, don't get this confused with a central angle. Okay? We talked about central angles a couple sections ago. A central angle is an angle whose vertex is at the center of the circle. And we said that a central angle is equal to its intercepted arc. Okay? Now we have another property saying that inscribed angles are equal to half of their intercepted arc. Right? So make sure that you don't get those ideas confused. Right? So say that's so if this angle is 70, this arc is 70. But then if I have an inscribed angle for that same arc, that would be half of that. 35. Okay. So a central angle is equal to its intercepted arc. An inscribed angle is equal to half of its intercepted arc. The vertex is always on the circle. So, I mean, I guess the one I drew up here actually goes through the center, and that's just a coincidence. An inscribed angle is just an angle whose vertex is somewhere on the edge of the circle. Sure. Right, a central angle is always in the center. Yeah. And an inscribed angle is on the edge, like your skin. Any other questions so far? Looks like an arrowhead. Alright, so let's try a couple then. Okay, let's take a look at 1, 2, and 3. Less. Glad you enjoy circles. Is it? Yeah, go ahead and try 1, 2, and 3 here. Shouldn't take you very long. Are circles fun because they're easy? Just No, they're batteries.
You like look on the back, all of them are clear. Some of them you get them on. You can see
A brand? Branding?
That is a brand. Right here. It's right here. It's really weird.
Who?
Your dad.
Oh.
I don't sing. I can't. What did you give? You said it hurts so bad. Why did you do that? Why would it not? Who would consciously like watch those out ever? Why? Because they were cooler at the time. That would burn you. You got another one.
All right. Did we get 72, 31, and 226?
No.
Okay, so these were all just, if we were given the angle, double it to get the arc. If we were given the arc, we would take half of it to get the angle. If we were given the angle, double it to get the arc. Okay? So the next two problems down below have to do with the idea that, let me zoom in a little bit,
Algebra.
that angles that intercept the same arc would have to be congruent. Right? So if we are looking first, we want to find the measure of angle U. So that is this angle right here. Well, that angle intercepts the same arc TW, as angle B. Okay, so those two angles are intercepting the same arc. That means they have the same measure. This way. Illusion. Exactly. So angle U would be 30. And if we wanted to find TW, that would be 60 degrees, exactly double the angle. So then the other part, right, to do a little bit of algebra, they ask us to find the measure of angle T. Well, if I look now at my other two angles, they both intercept arc UV. So angle T here intercepts arc UV, and angle W also intercepts arc UV. So to find x, I can set these two equal to each other because I know those two angles will be equal. They intercept the same arc. So 3x plus 4 equals 2x plus 9. The x is on one side, number is on the other. We get x equals 5. Is that my final answer? Yep. I need to plug it back in, right? So if I plug that back in, I will have 3 times 5 is 15, plus 4 is 19. So, alright. That was like you play softball, you're probably not. Alright, questions? Alright, go ahead and try 6 and 7 then. Yes. Yeah, so once you find the values of the variables, you plug them in to get angle A and then angle C.
I'm meant for like how we red and blue lines. What was the red line then before?
So we want to look at the two angles that intercept the same arc. So if I'm looking at angles that intercept arc AD, that would be angle B, and then also angle C.
How do you know what arc is? That was right?
Well, we're just looking for angles that intercept the same arc. So I can say these two angles, angle B and angle C, they both intercept arc AD. Therefore, those two angles would be equal to each other. So these two angles, angles B and C, they both intercept this arc, arc AD. Right? So if I'm looking at angle B, that's angle ABD, intersects the circle at arc AD. This angle does the same thing. ACD also intercepts the circle at arc AD. Since they intercept the exact same arc, those two angles have to be equal to each other.
Yeah, and so A, B, and A, B also B, C, right?
Well, you just named the two angles we were talking about. So, but like angle BAC and BDC would intercept arc BC. So those two angles would be equal to each other.
So how do where do they? But like you said, they intercept, right? So A and B really intercept, right? Same thing with B and C. How would you know? How do you know the difference?
So let's look at one angle at a time. So this angle, angle ABC, intercepts the circle at arc AD. Right? Now, I can erase this and look at this other angle, angle ACD, that also intercepts the circle at AD. So those two angles would have to be the same.
Oh, I see it now.
So then we could do the same thing for these other two angles. We could say, yeah, you could kind of think about it as like a flashlight beam, and then so we can say this angle. Yeah, there's lots of angles, lots of lines going on here. English 2, geometry, biology, and U.S. history 4. Algebra 1 and English 1. Yeah. Yeah, you'll take English 1 and geometry.
So is 6y minus 2 equal to A?
Yeah, so the 6y minus 2 would equal this angle. So that we could say 6y minus 2 equals 5y plus 8, because these two angles both intercept arc BC. So they would have to be equal to each other.
Oh yeah.
What's up? I mean, yeah, if you can figure it out before I show you how to do it, that'll expand your brain even more. All right, did we get 58 for angle A and 45 for angle C? just solve for x and y.
No, I did. I wrote down 45.
So questions on these ones? Let's go to the back. All right, so on the back, we can talk about inscribed polygons. All right, so the basic one, or I guess first we could define an inscribed polygon. Okay, it's just a polygon where every single vertex is on the circle. Right, so I could say that quadrilateral ABCD here is an example of an inscribed polygon because all four vertices are on the circle. Right? So, a couple of properties that we'll look at here. And the first one is an inscribed angle of a triangle intercepts a diameter or semicircle if and only if the angle is a right angle. So what that's saying, right, goes right along with what we just talked about on the front. So if I look at an inscribed angle right here, we look at angle BCD, well, its intercepted arc would be arc BD here. Well, if BD is a diameter, that's cutting the circle exactly in half. So we know that this arc would be a semicircle, it would be 180 degrees. Well, this inscribed angle then, angle BCD, would just be exactly half of that. It would be 90. Okay? That's what this first bullet is saying. Okay? If an inscribed angle intercepts a diameter or a semicircle, it's a right angle. Okay? But that just follows directly from what we just talked about. 180 degree arc, inscribed angle is half of that. Okay? The other bullet point might not be immediately obvious, but it still follows directly from what we talked about on the front. If we have a quadrilateral inscribed in a circle, then opposite angles are supplementary. They add to 180. So this example is actually kind of dumb. It has absolutely nothing to do with circles. It's just finding angles in a triangle. You don't have to use any of the properties that we've talked about. So let's jump down and take a look at one of the exercises together here. So in this first one, I know that WX is a diameter because it goes through the center of the circle. Okay, that means that arc WX would be semicircle, 180 degrees. That means that angle WYX would be half of 180, would be right angle. So now we can use our knowledge of triangles. Say all three angles in the triangle would have to add to 180 to solve for x. And so we could say x plus 12 plus x plus 90 equals 180. Combine my like terms. Subtract the 102 over. Divide by 2. And we get x equals 39. What's that? Yeah, there's not a lot of room. So then angle W, if I plug 39 in here, 39 plus 12 would be 51. What's that? Yeah, 1 and 2 both go with this circle. So I just plugged 39 in for angle W. Okay. Questions? All right, go ahead and try 3 and 4. Same type of problem. solve for the variable. I don't know. I did it in my head. Might have done it wrong. Oh, so
I got 16 here.
yeah, -6. We get x equals 16 and angle T is 58. Alright, then the final examples on here have to do with the inscribed quadrilateral. So we said our property for those, bless you, is that opposite angles are supplementary. So opposite angles would add to 180. So I could pick either pair here since I've got the same variable. I could say 75 plus 3x equals 180 or 110 plus 2x equals 180. Either of those would work. You add all four to 360. For this example, that would work, but it wouldn't work for this one because we've got different variables. So we would have to use the idea of that example, opposite angles. So far as Alright, questions on something like that?
No, not really.
Yeah, no, there was a question, I think 2 years ago, I don't think one showed up last year, on the air test, that they just gave you an inscribed quadrilateral, and I think they gave you like two angles, like this was 75, and this one was, I don't know, 60. And they said, well, from that information, what's the measure of angle A? Okay, so that's just this idea, right? Saying, well, I know that in an inscribed quadrilateral, opposite angles add to 180. So we would just say 180 minus 60 gets me angle A is 120. Okay, if there was a question, you didn't have to do any solving. It was just basically whether you knew that property or not. Opposite angles are supplementary. Right? Opposite angles in an inscribed quadrilateral are supplementary.